This is really hard concentration problems number 1, hydrochloric acid. Okay, so for each of the following acids and bases, calculate molarity, molality, and mole fraction. Hydrochloric acid has a density equal to 1.19 grams per ml, and it has a mass percent of 38. Okay. The first assumption that you're going to make is that when you're using the mass percent, that the total solution mass is equal to 100 grams. Of that, then, the solute comprises 38 grams, and the solvent is 62 grams. Let's take a moment to recall that the solute is the hydrochloric acid and the solvent is water. From that step, I'm going to figure out the number of moles of the solute equal to the mass, 38 grams, times its molar mass, which is 36.5 grams. That's 1.04 moles of our solute. The number of moles of our solvent is 62 grams times 1 mole over 18 grams. That means we have 3.44 moles of our solvent. At this point, I'm ready to do the mole fraction of our solute, which is equal to the number of moles of the HCl over the total number of moles of the solution. That would be 1.04 over the quantity 1.04 plus 3.44, giving us a mole fraction of 0.232. Using the density of the solution, I can figure out the volume of our solution. We have assumed that we have 100 grams of solution. We know the density of the solution, therefore I can figure out the volume of the solution. So the density was given at 1.19 grams per ml. We've assumed that we have 100 grams of solution, so the volume that this would occupy is equal to 84 mLs, which is equal to 0.084 liters. This time I can now figure out the molarity of the solution, which is equal to the moles of solute over the liters of solution. So that would be 1.04 moles over 0.084 liters, giving me a molarity of 12.4. Now I can figure out the molality, which is the moles of solute over the kilograms of solvent, which is equal to 1.04 moles of the HCl. Earlier in the problem, we figured out that we have 62 grams of our solvent, which is 0.062 kilograms. So our molality is 16.8 molal. Oops, forgot a unit.